So we have this interesting question, which is a combination of logarithms and series. So let's see how we can solve this question. We need to find the sum of this series, which is a logarithm series. So first of all, we have this one rule for logarithms. Log base A B. Whenever we have something like this, we can write it as log B over log A. So we will be using this rule. Okay. So let's apply this rule on the first term. If we apply this rule here, we will get 1 upon log E upon log 3. Now we can rewrite this as log 3 upon log E. Yes. So we will be rewriting our first term as log 3 upon log E. Similarly, we can write the second term as log 3 upon log E square. Third term can be written as log 3 upon log E raised to power 4. And so on, we will be continuing this series. Yes. After this, we will be applying one new rule of logarithms. Let's see what is that rule. If we have log A raised to power m, this power comes outside and this becomes m log A. Yes, so we will be using this rule in the next step. Let's see how. The first term will remain as it is, log 3 upon log E. But in the second term, look at the denominator. We will be applying this rule in the denominator. So if we apply this rule, this will become 2 log E. And in the denominator of third term, this will become 4 log E. And so on, the series will continue. Yes, I hope you have understood till this step. Let's see what we can do in the next step. In the next step, we can take log 3 upon log E as common. Yes, because log 3 upon log E is there in all the terms. Now we will be left with 1 plus 1 by 2 plus 1 by 4 and so on. The series will go on till infinity. Yes. Now if you look carefully, this series is nothing but a geometric progression. This is a GP. Yes, this is a geometric progression. And what is the sum of geometric progression till infinite terms? Let's see. The rule is sum of infinite terms in a geometric progression is a upon 1 minus r, where a is the first term and r is the common ratio. So in this case, a is 1 and r is 1 by 2, correct? Now we will be using this rule to find the sum of this GP or geometric progression. Let's find the sum. So we will get log 3 upon log E as it is and multiply by the sum of this series, which is a upon 1 minus r. A is 1 times 1 minus r. R is 1 by 2. If we simplify this, we will get log 3 and base E, correct? Times this. If we simplify this bracket, we will get 2. So the sum of this geometric progression is 2. We can rewrite this as 2 log base E 3, correct? Because 2 is getting multiplied with this. Now you remember the rule that I shared in the beginning? This 2 can become the power of this 3 if we simplify this further, correct? So we can rewrite it as log base E 3 square. So the most simplified answer, the most simplified sum of this series will turn out to be log base E 3 square is 9. Yes, so this is the most simplified answer for the sum of this series. The sum of this series up till infinite terms will be log base E 9. I hope you have understood this solution.